Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Lecture for grade 9, subject chemistry, chapter number 7, that is electrochemistry. And also we will do the exercise of this chapter. This is lecture number 25, and here is your teacher, Mrs. Saira Jamal. Dear students, in this lecture we will discuss the prevention of corrosion. So prevention of corrosion is an important way of conserving our natural resources. So following methods have been devised to protect metals from corrosion or from rusting. The first method of prevention of corrosion is coating with paint. Corrosion can be prevented by painting the metal so that it does not come in contact with oxygen and moisture and other harmful agents. So other harmful agents means acids or bases. Paint is cheap and easily applied. Paint is used to protect many everyday steel objects such as cars, trucks, trains, bikes, bridges, etc. Paint also provides visual appeal. The objects, they looks very nice, very pretty, very attractive, and also the paint protect the objects, its parts, from the exposure toward oxygen, moisture, and other harmful agents. You can see in this image that the object which is painted looks nice and attractive, and definitely this paint will protect it from corrosion. Next method is by alloying. The tendency of iron to oxidize can be greatly reduced by alloying it with other metal. Alloying, you know that by making or by mixing two or more metals together so that their stability will increase, or it will enhance the stability of the metal. For example, stainless steel is an alloy of iron, chromium, and nickel. These three metals are mixed together to form an alloy, which is called stainless steel, and it is very important, alloy, which is used in making the pots and utensils. It is protected from corrosion by an outer layer of chromium oxide, same like aluminum, same like iron. As I told you in my previous lecture, that they form a protective layer, but in case of iron oxide, the layer is porous, while in case of aluminum oxide, the layer is tough and hard. Same like the aluminum, this chromium oxide layer is also tough and hard, and it will protect the the chromium or protect the steel from corrosion. You can see here the gold. Gold is, I told you that 100% or 100% gold we cannot use to make jewelry because that will be very soft. So in order to make designs of jewelry, the gold is mixed with copper. So we have copper gold alloy, and you can see that it is made by dipping the copper in gold water, and first it is de-alloying by cleaning it, and then by dipping it in the gold we can make the gold plated copper. The third method is coating with a thin layer of another metal, which we just discussed in the previous lecture, which is called the electroplating. So metals that readily corrode can be protected by coating with a thin layer of another metal, then resist corrosion. This can be done by tinning, galvanizing, and the third one is electroplating. The first one is tinning. What is tinning? In the process of tin plating, clean iron sheet is dipped in a bath of molten tin. It is then passed through hot pair of rollers. Tin protects iron effectively since it is very stable. You can see in this image that first the tin steel, or the steel is first starting from the left side. First, the mild steel is dipped in dilute sulfuric acid, which will act as a pickling, like it will remove the rust or the corroded parts from the steel and then clean it. That clean steel is then passed through roller to make it smooth. Then it is dipped in the zinc chloride flux. Zinc chloride flux means a bath of a zinc chloride which contains zinc in it. Definitely zinc chloride has zinc ion and chloride ion. So by dipping it in the zinc chloride bath, what will happen? The zinc will adhere to the surface of the steel, and then it is passed through the squeeze roller which will make it smooth and will give it a proper smooth shape. It is then dipped in the oil or grease. As this one is, the flux is very hot, and the hot layer of zinc will adhere at the surface of the steel. So after passing through the rollers, the sheet of steel is dipped in the oil or grease. The function of the oil or grease is that it prevent or it protect the steel to come in contact with the oxygen or moisture of the atmosphere, and this oil or grease will prevent it from the corrosion. So then the final product is tin plated steel, which is also called tin steel. This hot molten, you can say, solution has a temperature of 250 to 290 degrees Celsius. The second part of this coating of one metal with another metal is galvanizing. Galvanizing is coating with zinc, like coating of steel with zinc. So the process of galvanizing consists of dipping a clean iron sheet in a hard zinc chloride bath and heating. After this sheet is rolled into zinc bath and cooled. Now you can see in this image that the first step is degreasing. First the uh, zinc, sorry, the steel or iron bar is cleaned by degreasing means removing the oil, and then rinse it, and then by pickling bath means I told you by dipping it in acid. So by dipping it in acid, all the corroded part will remove. Then it is rinsed. After rinsing it, it is dried, and after drying it is dipped in molten zinc bath, which contain hot or melted zinc chloride over here. The stainless steel or the steel or iron bar is dipped in the zinc bath, and after passing through the zinc bath, it is then cooled and checked that either it is like plated completely or not. So this is the whole process of galvanizing. Although it is same like the tinning, almost same like the tinning process. Then the next one is electroplating. Electroplating actually is same like the plating, simple plating, like where one of the layer is, you can say, the layer of one metal is formed on another metal, that is just plating. But electroplating involve actually electric current or electricity. Through passing electric current, the one metal is deposited at another metal electrode. So the pure metal or the metal which we want to make a layer of it, we will take it as a anode, and the steel or iron on which we are making the layer, we will take that electrode as a cathode. So electroplating is the process of applying a metal coating on another piece of metal or another conductive surface. Conductive surface definitely means a metal, because metals are good conductors of electricity and heat. Through an electro deposition process, in electroplating, the deposited metal becomes part of the existing product with the plating or coating. Definitely this copper electrode. Suppose in this case we are using electroplating of copper. So we will use this copper as an anode, and then the other one is that electrode where we are going to electroplate this copper on it. So for this, if suppose if this is zinc, so we are electroplating copper on the zinc. So the zinc will act as a anode, and the copper will act as a cathode. if we are doing zinc electroplating. But if we are doing copper electroplating, then we will use copper as an anode and zinc as a cathode. The last point is cathodic protection. So cathodic protection is the process in which the metal that is to be protected from corrosion is made cathode and is connected to metals such as magnesium or aluminum. These metals are more active than iron, so they act as anode and iron as a cathode. So definitely, if these metals are more active, so when they will come in contact with oxygen or moisture, so these metal will react with the moisture or oxygen, and then the iron will get safe. More active metals themselves oxidize and save iron from corrosion. Cathodic protection is employed to prevent iron and steel structures such as the underground pipes, underground tanks, oil rigs, etc. So to prevent them from corrosion or reaction with oxygen and moisture, these cathodic protection method is used underground and even in marine environment. You can see here, this is the pipe, iron pipe, which is connected with magnesium. And I told you this magnesium will act as an anode because the more active metal always act as an anode. Keep this in your mind that the more active metal also act as an anode and the less active metal act as a cathode. So this magnesium will act as an anode and the pipeline, like the pipe which is made up of iron, will act as a cathode. So as I told you that what will happen when the moisture or the soil is moist, definitely in moist soil, as this magnesium will act as an anode, it is more active, so it will get oxidized by losing electrons. So those electrons will then move from anode towards the cathode, and when they will move from anode towards the cathode, so oxygen will then reduced by gaining those electrons and will form water, and then in turn iron will get safe from reaction. You can see oxygen react with the hydrogen and then electrons which come from the magnesium. One magnesium is giving 2 electrons, so 2 magnesium will give 4 electrons and will give 2 moles of water. So you can see that there is no reaction of iron, only the reaction of magnesium, reaction of oxygen. It means that the iron will get safe from corrosion. Then coming towards the exercise, the first question is MCQ, correct, encircle the correct answer. In which of the following changes the nitrogen atom is reduced? Nitrogen atom is reduced means nitrogen oxidation number decreases. So let us see the oxidation number of nitrogen. You know that the oxidation number of nitrogen is 0 because it is in the elemental form. And in elemental form, the oxidation state of an element is 0. So from 0, it is converted into oxygen is -2. So definitely nitrogen will be +2. -2 +2. So from 0, nitrogen undergo +2 oxidation state. So +2 is greater than 0. So increase in oxidation state or increase in oxidation number is called oxidation. In this case, nitrogen is oxidized, but in the question they ask about the nitrogen reduction of nitrogen. Same is in this case, nitrogen is 0 and here 2 oxygen, so 2 twos are 4. 1 oxygen is -2, here we have 2 oxygen, so 2 twos are 4. So -4 is the oxidation state of oxygen, so +4 will be nitrogen. Again, nitrogen is oxidized because its oxidation state increases from 0 to +4. In this case, the nitrogen from 0 undergoes -3 because hydrogen is more electropositive than nitrogen. So hydrogen will be +1. And here we have 3 hydrogen, so +3. Definitely nitrogen will be -3. So 0 is greater than -3. In this case, nitrogen get reduced because its oxidation state decreases. Same in this case, from 0, nitrogen goes to 1 oxygen is -2. We have 3 oxygen, so 3 twos are 6. 6 -6 +1 is +5. So the oxidation state of nitrogen in this case is +5. Again, increasing oxidation state is called oxidation. In the A, B, and D option, nitrogen is oxidized, except C, where nitrogen is reduced because its oxidation state changes from 0 to -3. Number two, which of the following changes reaction is an example of oxidation? Again, chlorine molecule to chloride ion. Chlorine molecule is 0 and chloride ion is -1. So from 0 to -1 is reduction because oxidation state decreases. And silver atom to silver ion, silver atom, silver is 0, silver ion is +1. So from 0 to +1 is oxidation because oxidation state increases. And oxygen molecule to oxide ion, oxygen is 0 and oxide ion is -2. So this is a reduction. And iron 3 to iron 2, and iron 3 will gain one electron, and gaining of electron is again reduction. So the correct option is silver atom to silver ion from Ag0 to Ag+1. Third one is which of the following elements in the given reaction is reduced. Now you can see that zinc oxide is, in this case, zinc is losing oxygen atom, and loss of oxygen is called reduction. So as zinc is losing oxygen atom, so we can say that zinc in this case is reduced by losing oxygen atom. So which one is the correct option? Zinc is the correct option. Number 4, consider the following reaction. Hydrogen sulfide when react with chlorine will give hydrochloric acid and sulfur. So in this reaction, what does hydrogen sulfide behave as? So you can see hydrogen sulfide is losing hydrogen ion or hydrogen atom, and loss of hydrogen atom is called oxidation. So the element which is oxidized will act as a reducing agent. As sulfur in hydrogen sulfide is oxidized by losing hydrogen atom, so it will act as a reducing agent. Number 5, the oxidation state of chromium in potassium dichromate is, by solving you will see that the oxidation state of 2 chromium ions are +12, but we need for 1 chromium. So +12 divided by 2 will give us the answer 6. Which of the following statement is not correct about the galvanic cell? Cations are reduced at cathode. So this is correct. Yeah, cations are reduced at cathode. Anions are oxidized at anode. Correct. Electrons flow from cathode to anode. This is wrong because electrons always flow from anode to cathode. Oxidation occurs at anode. This is correct. So the wrong answer is, the wrong statement is electrons flow from cathode to anode. Correct answer is electrons flow from anode to cathode. Number 7, which of the following is not true about the Daniell cell? Half cell of an active metal acts as cathode. That is not correct because active metal, I told you, will always act as an anode. Most active metal means which can easily oxidize by losing electron. So in this case, they say that half cell of an active metal will act as a cathode. No, this is wrong. Half cell contains an element in contact with its ion in aqueous solution. Correct. A salt bridge connect the two half cell. Correct. A spontaneous oxidation reduction reaction generates electricity. Yes, it is correct. Number 8, which of the following do not involve electrolytic process? Refining of copper is electrolytic cell. Manufacture of sodium from sodium chloride, that is down cell, is electrolytic cell. Electroplating of steel is electrolytic cell. Reduction of metal oxide by oxidization. No, this is not an electrolytic cell. We can just combine metal oxide and by using a reducing agent, we can reduce it. There is no need of electric current or any electrolytic cell. Galvanizing, we just discussed it now, that it is coating with zinc, coating of steel or iron with zinc. The last one, MCQ, is which of the following is true for the Nelson cell? Sodium metal is produced at anode, yes. Chlorine gas is produced at anode, no. Chlorine gas is produced at cathode. Hydrogen gas is sorry, which of the following is true for the Nelson cell? Yes, chlorine gas is produced at anode. Chloride ions are negatively charged. They will move towards the anode, which are positively charged. So chlorine gas will go towards the anode and will get oxidized there. Sodium metal is produced at anode. So sodium metal is produced at cathode, and hydrogen gas is produced at anode. Hydrogen gas is produced at cathode. Sodium ions are not produced as cathode. So again, this is wrong. Correct option is chlorine gas is produced at anode. Coming toward the short question answer, the first short question is, what is oxidation state? Oxidation state or oxidation number is defined as the number of charges an atom will have in a molecule or in a compound. The elements that show an increase in oxidation number are oxidized, and the elements that show a decrease in oxidation number are reduced. So in other words, we can say that the apparent charge present on an atom in a molecule or in a compound is called as oxidation state or oxidation number. If the oxidation state of an element increases, it means the increase in oxidation state is called oxidation. The process is called oxidation, and the element we say is oxidized. And the element that show a decrease in oxidation number or oxidation state is called reduced. Question number 2, what is the oxidation number of chromium in chromic acid? This is the formula of chromic acid, H2CrO4. So in order to find out the oxidation state or oxidation number, we will first take that molecule equal to 0, then oxidation state of hydrogen, and we have 2 hydrogen atoms. So 2 oxidation number of hydrogen plus oxidation number of chromium plus 4 into oxidation number of oxygen equal to 0. So 2 oxidation state of hydrogen is plus 1 because it belongs to group number 1. Oxidation number or state of chromium we have to find out. 4, and oxidation state of oxygen, it belongs to group number 6. So it needs 2 more electrons to complete its octet, minus 2. So 2 ones are 2. Oxidation number of chromium we have to find out. And for the 4 oxygen atom, 4 twos are 8. 4 twos are 8 when by subtracting these values, like minus 8 plus 1 will give us the answer minus 6, and when if you will shift it to the other side of the equality sign, that will be plus 6. So the oxidation state of chromium in chromic acid is plus 6. Question number 3, identify reducing agent in the following reaction. First of all, we have to assign the oxidation number to each atom. Copper plus 2, oxygen minus 2, hydrogen in elemental form is 0, copper is 0, and oxygen minus 2. One hydrogen is plus 1, so for 2, it will be plus 2. Now, we have to find out the reducing agent. So let us check which one is oxidized. Copper from plus 2 undergoes 0, it is reduced. And the other one is hydrogen from 0 undergoes plus 1. It means increasing oxidation state of hydrogen show that hydrogen is oxidized and will act as a reducing agent. Because the oxidation number of copper decreases from plus 2 to 0, so copper oxide is an oxidizing agent. There is no 3 here, this is just CuO. CuO is an oxidizing agent. Similarly, the oxidation number of hydrogen increases from 0 to plus 2. One hydrogen is plus 1 and for 2 plus 2. Therefore, hydrogen is reducing agent. Question number 4, write chemical reaction that occurs in Nelson cell. At anode, I told you oxidation takes place. At cathode, always reduction takes place. So chloride ions are negatively charged ion. They will go toward the positive electrode, which is anode, and at anode, oxidation of chloride ion will takes place. Chloride ion will loses 2 electrons. One chlorine is losing 1 electron, so we have 2 chloride ions, so 2 electrons, and will give us chlorine gas. It means that at anode, chlorine gas is produced by oxidation of chloride ion. At cathode, reduction takes place, so 2 water molecules, they will gain 2 electrons and will form hydrogen gas and hydroxyl ion. So by overall reaction, we have at this side 2 chloride ion, 2 water molecule electron, and electrons will cancel out. And at the product side, we'll have chlorine molecule, then hydrogen gas, and then hydroxyl ions. Now we have hydroxyl ions and sodium ions as well. The solution contains sodium ion and hydroxyl ion because we use the saline solution. That is, we use the concentrated solution of the sodium chloride, which is called brine. So brine contains sodium ions as well. So this hydroxyl ion and sodium ion will react together and will form sodium hydroxide. You can see sodium ion and hydroxyl ion will combine together to form sodium hydroxide, which is the final product of Nelson cell. Along with sodium hydroxide, the side products are hydrogen gas and chlorine gas. Question number 5. Why tin plated steel is used to make food cans? They are made from steel with a tin coating of tin to prevent corrosion. Tin plated steel is used to make cans, food and beverages industries use tin plated steel cans. This is because the component of food beverages and preservatives contain organic acid and their salt. They may form toxic substances by reacting with iron. So that's why to prevent their reaction with iron is plated with tin. These acid and salt are corrosive, so tin plated steel is non-poisonous and prevents corrosion. Question number 6. Explain one example from daily life which involves oxidation reduction reaction. So one of the important method is redox photography. A photographic film is basically an emulsion of silver bromide. It is, you can say, strip having silver bromide in it and in gelatin. Sodium bromide is mixed with gelatin. When this film is exposed to light, definitely when the film is we put in a camera and when we press the button of the camera, what will happen? This silver bromide will come in contact with the sunlight. So silver bromide granules become activated due to the sunlight. This activation depends on the intensity of the light falling upon them. When exposed film is placed in the developer solution, this exposed film is then put it in a solution which is called developer solution, that is actually a reducing agent. So hydroquinone, which is a mild reducing agent, is mostly used as a developer. Hydroquinone. In hydroquinone, the activated granules of silver bromide are reduced to black metallic silver. Reduced silver atoms form image. These reduced silver atoms form image. You can see silver is reduced by gaining electron to form silver metal or silver solid. Inactivated silver bromide is removed from the film by using or by dipping it in another solvent which is called fixer, and we mostly use sodium thiosulfate for this purpose. And the areas of film exposed to the light appear darkest because they have the highest concentration of metallic silver. Thus, photography involves oxidation reduction reaction. You can see in this image that if these person they are come in contact with the or with the camera's light, what will happen? The image will fall on the film, and then by keeping that image or that film into developer. I told you hydroquinone is used as a developer. Then that hydroquinone, after putting it in the developer, it is then placed in a fixing solution. The function of the fixing solution is that it will remove the extra silver bromide and will convert the or reduce silver into silver solid. And then the image is visible. You can see after dipping it in the fixer, the image is visible, and then the print out of that image is taken. That is actually the developed picture. So this is all about the photographic film that I told you is used, and you can see here that oxidation reduction reaction takes place in this case as well. You can see that the silver it get reduced by gaining one electron to form silver solid or silver pellets. So silver is reduced by gaining electron, and it is converted. It is also called metallic silver or silver atom. So photography also involves the oxidation and reduction reaction, because I told you in the film silver bromide is present, and that silver bromide when exposing it in the sunlight or flashlight, it will convert it into black and white negative. That black and white negative show that the black part is actually the part of the silver bromide which come in contact with the light, which convert the white silver into black color, and the white part show the image of the person's because the light cannot pass through the body of the person, and that's why their body protect the silver bromide on film from exposure towards the light, and hence the shadow appear on the film, and we can get or we can make the picture of those persons by first of all I told you by exposing the persons to light, and after exposing the persons to light, the film is then passed through developer, and hydroquinone I told is used as a developer solution, and it will give an image. That black and white image actually our visible image is actually then dipped in a fixer or in a fixer solution. Mostly hyposodium thiosulfite is used for, or sulfate is used for this purpose, and after fixing a print out of that picture has been taken. That is actually the required picture. So this is of redox photography, in which oxidation and reduction reactions are involved. So dear student, hope you understand this lecture. Inshallah, we will do the rest of the questions in our next lecture. Till then, take care. Allah Hafiz.